Okay, so we're going to look at how to do a strength simulation test on Autodesk Inventor for you guys. So let's say this is our product. Now you can't just do it easily. It's not very easy just to do a strength test on here in certain areas, especially as we may not have assigned the materials quite correctly. So on here, what we're going to do is this is an assembly, but one of the parts that was made was this part, and that was the frame. Now if I was doing this again with strength testing in mind, I probably would make it, but without the piece of wood. Anyway, to kind of just go with this, the first thing that you want to do is you want to make sure you've assigned a material to this part, and we're going to assign it to steel and mild steel. Now again, I could try and test it, but because this piece is not wood, it becomes problematic. So what we're going to do, and what I recommend for you guys to strength test and to see if your material is going to be strong enough, is to look at one particular part. So I'm going to look at this part here, just this cross-sectional beam here, which are the supports for holding up the actual table. Alright, so I've now redrawn this steel top bar here and allocated the material by clicking this button or clicking on here, the steel, mild steel, alright, which is what we're working with. And that assigns that material to everything, which is why this kind of is not appropriate for here, because not everything on here is mild steel. Now we're just going to test this. Now it's kind of joined in this point here and this point over here and supported from underneath there. So I'm just going to do this in a really easy way for you guys so that you can kind of see how to do it. So you have something here which is called stress analysis. It's also underneath environments, okay, and it's a simulation, so stress analysis button there as well. So I'm going to click that to start off with. And that now loads. It's actually loading something that I've done before, so hopefully I can just kind of click and delete that, and we can try and do it again. So the first thing to do here is to, once you've clicked on that stress analysis, is to create a new simulation. Now you can just leave this all as it is for the moment and just click OK. Alright, so this is the first simulation that we're going to do. Now the first thing we want to do, once we've done that, is to select the fixed points. So come up to this button, these are the constraints, and we're going to select it here. You can go into this quite a lot as to whether they are welded, but I'm just going to zoom in, and I'm just going to say that this point here is going to be welded. So I'm going to click on that section there. So that now becomes a fixed point. I'm also going to do it on the other side. So bring it around, and this part here is also going to be fixed. So now I've got two fixed points, and they kind of add these symbols in for them to show that they are fixed points. So they're both there now, and then I'm going to click apply and get rid of that. Okay, so that's now created my fixed points, and now I'm going to add a force to it. Now force here is measured in newtons, and I don't know a lot about maths, but I know that something like 996 or something like that newtons equals about 10 kilograms. Alright, so we're going to first select the location. I'm going to put the force going straight on top down like that. Spreads it all the way out across that surface. Then I'm going to do a test for 100 newtons, which is roughly just over 10k, I believe, 10 kilograms that you're putting onto it. Okay, I'm going to click OK there. And then I can get rid of that. Now that's put in my fixed points, and it's put in a force. And now I'm going to simulate that. So click on the simulate button. It's ready to run, and now I can press run. This can take a little bit of time. If it does, well, hopefully it won't, but we'll just see. You can kind of skip fast over this part of the video. Until you see the kind of it complete. Alright, there you go. So that's now complete, and it's showing you where it has come. Now the displacement here doesn't mean that's how far it's actually going to displace. That's just showing you the direction which it would displace. Alright, and so it's easy to see which way it's going there, but it's not actually doing it that much. So this isn't a realistic displacement of what's actually happening. Now you can come in here, and if I just bring this across here, you can kind of start to see what it's suggesting here on this side. Now, importantly, we want to know, is this the kind of XY or XX or YX axis which it's doing it in? And there's a couple of kind of ways of trying to find that out. So we can look on these different areas here. So we've got our kind of constraints, our material. These are our parts, displacement, you can see there. We're going to go into the displacement here, and you can see we can either highlight the X displacement, all right, the Y displacement, okay, and the unit is in millimeters, and the Z displacement, all right. And what we're really looking at in this section is the Y displacement. It's the one that's kind of moved the most, and you can see it here. Now it has displaced in the red area by 0.03 millimeters. So that is a tiny amount that it's come down, all right, and that's you showing that your test kind of works nicely there, all right. So with that in mind, we've kind of completed this first analysis, all right, and you can start now to kind of export those. So we can put a result here. I would personally take a screenshot of this. I would have a look at this area. You can see how much it's displacing in each of these areas by how much it is here. You can also export a report, all right, and that can click OK, and that should export it out, and you can see it's exporting all the different areas there, and it will put it into a web page for you, again, for you to kind of show how much displacement is going. We'll just wait for that to happen. All right, and here it is. So you can see what's happening here. All right, you can see the materials. It's talking about all the different materials, the yield strength and the Young's modulus there. All right, and you can see the selected face here. All right, and you can see again, this bit is going to be telling us how much we've put on. So we put our all onto the Y. So that's the one we're going to look at down there, and it's 100 newtons. Okay, going down to Y, and we can kind of zoom down until we start to see this part here. And this is the figures for the stresses. All right, it's not, you can see it's not showing nicely, but you can see the unit is MPa, so we're not looking at that one, megapascals. We're looking at the unit when it comes down to millimeters. There we go, and you can see which areas. So here we're looking at the type here, and it says the maximum is 0.36 displacement there. All right, when it comes to the displacement this way, is pretty similar. All right, and then here we're going on to UL. Don't worry about those parts. Okay, so if I kind of move on from that, and I think I can finish my analysis there, and or just didn't mean to actually finish it there. I want to come in and I want to come to my load there. So don't finish it, just click on load. All right, and we are going to remove the load. I believe we can do that now. We have to open it up. There we go. So now right click and we can delete that. Okay, so the load's gone. And we're going to put the force back on, but instead of doing that this time at 100, we're going to do it at 1000. Okay, so now that is more like 100 kilograms. So a heavy person. Apply. Get rid of that. We're going to simulate that. Run. Okay, there again, shows it again. It's Y displacement. Now that Y displacement, being a Y displacement, is because that's the way I drew it out. But let's click on Y displacement. Okay, millimeters. Instead of 0.03, it's now 0.36. Okay, so now it's 0.3 of a millimeter rather than 3/100ths of a millimeter that is now starting to change, and you can see all the different areas. So that's just by adding that amount. Again, very minimal, and you can see that the table is by far strong enough. And you could be testing this with different materials, but that is a perfectly good strength test for you to see the strength of your material. You could run this again with maybe you know, maybe I could draw myself a piece. If I just finish this analysis, okay, and I could draw myself maybe one of these bits of wood, this central piece of wood, and lock it in on 2 places. That would be another one that I could do for your piece of oak on the top. Okay.